Thank you, Remedios, for your introduction. And I want to talk to you about the potential biological hazards of raw milk. And maybe, can we compare it to other food products? Dr. Delbes just told us that it's only responsible for about 2% of all the outbreaks in the European Union. That is already one estimate. Now, can we really know how dangerous it is? Can we quantify the risks? That's actually a very hard question to answer, and I will not be able to give you a very straight answer today, but I would try to help you manage the risks and understand them. So Remedios have already introduced me, but I work mostly in preventive veterinary health and working with healthy animals and healthy systems. But one of my tasks and one of my passions is to work with you, raw milk producers, raw cheese producers and artisanal cheese producers, to help you make your systems really safe so that you don't create any hazards for your consumers. And also to help work with your regulators and help them understand the risks so that they don't come up with stupid rules that are killing or sterilizing your production. So raw milk is becoming increasingly popular, and all over the European Union, all over also North America, we see an increasing consumption of raw milk, not only raw milk cheese, but also raw milk. And this has become quite interesting. And many farmers see now that as a potential of getting some extra income. If they can start selling raw milk directly to consumers, they can make some more money than just selling it to the big creameries, such as Danone. They can get 4 times as much paid for the raw milk. But as the picture shows here of this vending machine, it's not as simple as just pushing the cow into the vending machine and thinking that that's the way to squeeze out some extra money out of the business. Producing raw milk requires a lot of knowledge about how to produce safe raw milk so that you don't put your consumers at risk. And there are, of course, as Dr. Delbes now showed, there's a lot of bacteria involved in raw milk. And I'm going to focus on the ones that are what we call pathogenic, that can cause disease, and then specifically those that are zoonotic pathogens. Those are the ones that are transmitted from animals over to humans. So what is really risk? Well, according to the laws of food legislation, risk should be determined based upon a risk analysis. And FAO, WHO, and the Codex Alimentarius, they've developed a framework how to assess these risks. It involves defining what is the hazard, how is it characterized, what is kind of bacteria is it, how does it kill, what's the risk of a consumer being exposed to this hazard, and then how big is the risk that someone will get sick if they are exposed. So all of that needs to be done in order to properly assess what's the risk of a product. But this hasn't really been done to dairy products, but I will show you as much what has been done in certain contexts, but there's a lot left to be done. Now, if you just look at the number of foodborne disease cases, and here I took the data developed by the European Food Safety Agency in 2017, every year we have approximately 250,000 cases of Campylobacter that are diagnosed. There's a lot of undiagnosed cases, but those are the ones diagnosed. There's approximately 100,000 cases of Salmonella. There's over 6,000 cases of the Shiga toxin producing E. coli, and there's 2,500 cases of Listeria. So all of these, that's on a yearly basis. There's a lot of people getting sick from food. Campylobacter is most common, and Listeria is most fatal. But what's the risk from raw milk and raw milk products? Well, the European Food Safety Agency actually did a hazard report of raw milk in 2015, and they were specifically looking at raw drinking milk. And they considered that these are some of the bacteria that can cause threats to humans, and there's also some parasites and some viruses, but they're predominantly bacteria that are a hazard to humans. And they said, well, they were looking through all the data in order to say, what are the risks? And they came up, they couldn't really quantify the risk. All they could do was look at reports. And there's plenty of reports. Every time somebody gets sick from raw milk, it's going to be published everywhere in scientific journals and in the newspaper. So they could look at reports. They found 27 reported outbreaks in 5 years. Most of them were from Campylobacter, 1 from Salmonella, 2 from Shiga toxin-producing E. coli, and a few viral diseases. Most of these were from raw cow's milk. There were a few raw goat milk also. So in essence, they said, we're talking mostly bacterial hazard here when we're talking raw milk consumption. And you know the common names, Campylobacter, Salmonella, toxin-producing E. coli. Listeria is maybe not such a big risk from raw milk consumption as from raw cheese products. Then there's also, of course, in certain areas of Europe, we have more hazards due to Mycobacterium bovis and Brucella. There are also some viruses and parasites that are zoonotic that can cause disease, and they may become more important in the future. Of those, tick-borne encephalitis virus has been linked to a few more outbreaks in raw milk. There's some concerns about the bovine leukemia virus, its potential to cause disease, and there are also some reports maybe that Cryptosporidium could be involved, but I think that maybe was more due to the fact that the consumer was also having their children kiss the calves or something when they were picking up their milks. So these are some possibilities here. Well, you said, well, can't we just test the milk to determine the hazard? Well, that would be the easiest way. And of course, that's what we've been doing for a long time, and that's what the regulatory authorities have been doing. They always go out and they take samples, right? And previously, most sampling was taken based upon bacteriological culture. You would culture bacteria on agar plates and see what you find. But this took a long time, and it was time-consuming, so we developed better diagnostic techniques, such as antigen capture, ELISA. We have polymerase chain reactions. We have some ELISA antibody detection systems. And all of these systems can have good sides and bad sides. Some of them are too sensitive. They detect something when it's really not there. And other ones just don't find it when it's there. For example, if you want to take a sample, you know the salmonella in the small sample, you culture it, there's a 50% chance you're actually going to find the salmonella. So it's not very sensitive. So really, to look for pathogens in the milk itself is a very insensitive method. It's a bit like looking for a needle in a haystack. It's a very low sensitivity. So if you have authorities coming out to your farm and say, we need to take some milk samples to look for pathogens, just let them. It's not a good method. It's a very insensitive method. If you really want to find something, you really should maybe look in the milk filters instead of in the milk samples, because the milk filters, they filter hundreds, sometimes even thousands of liters, right? And in these milk filters, you're more likely to trap potential pathogenic bacteria. So milk filters have been used increasingly to look at risks in raw milk. But also, if you find something in a milk filter, it might not really tell if there's a risk with the raw milk. It only meant that you found maybe one bacteria. And you heard Dr. Delbes, she talked about how many gazillions of bacteria there are. Maybe one bacteria in a milk filter is not a problem. So it's very difficult to assess. But if you're on a farm and you want to really know if there's something found in your milk, you should work with the milk filters. But then you need to know how to interpret those risks. Because unfortunately, it's very hard to say how risky it is. And over the decades that we've been working, ever since we started pasteurizing here in the middle of the previous century, we have inappropriate or very poor quality scientific evidence for the dangers of raw milk. Most of these reports are individual outbreaks. As I said, if you have a case, it's identified it was due to raw milk, you're going to find it published in scientific journals, and the researcher gets so interested they write it up everywhere, and in the newspapers, it lands on the front pages. It's interesting stuff. And then they start saying, well, raw milk, if you compare it to pasteurized milk, it's so much more dangerous. But it's really not valid comparison. It's really, why don't you compare it to raw eggs or raw bean sprouts or something else raw, or raw beef? We like eating, so they're using also, many times, they're using bacterial prevalence data without looking at the level of contamination of a product. You need more than one salmonella to get sick. So if you find one salmonella in a product, it doesn't really mean that you're going to be sick from it. So many times it's just if they find something, they say it's a risk. If it's one listeria, that's enough. That's even if we know that we need higher dose to get sick. Another challenge with raw milk disease outbreaks is that it's much easier to identify the source of a foodborne outbreak if the commodity that has been causing the outbreak is very rarely consumed. For example, if people get sick from chicken, well, everybody eats chicken every week, and they don't know from where that chicken came. So usually you never find what was the reason for the disease. Or if somebody got sick from bacteria in pasteurized milk, well, everybody drinks and eats some pasteurized milk all the time. So in the end, the researchers are never going to find the cause. But if somebody gets sick and then the researcher says, or the inspector said, did you drink raw milk or eat raw cheese? And you say yes, and then they find your brand in the refrigerator, then they can trace it back. So it's much more likely that you will find a disease outbreak if it was due to a specific commodity such as raw milk. So we have what I call a traceback bias. And then we have this publication bias in scientific journals and ProMed. And this is something I constantly have to work with to explain to scientists and regulators and inspectors, because they just seem to all say the same old thing. Raw milk and raw milk cheese are so dangerous, without really assessing how they are basing their opinion. So many bacterial prevalence data that researchers are using to say that raw milk is dangerous is based upon milk from conventional production, from large-scale dairies maybe, or from dairies that are sending all their milk to pasteurization. But this milk is not representative for what you do, or for what certain dairies do that are specifically producing raw milk for direct consumption. So it's a bit like comparing apples to pears. So they're using data from farmers that know that, well, they're going to pasteurize my milk anyway, so I'm not terribly concerned about the hygiene at milking. They're comparing that milk to what you're doing. You know exactly what you're doing because you're in this business, right? So if you look at this slide, you don't try to read everything, but I said this is what they've been looking at studies where they're looking at prevalence of pathogens in raw milk. And you see in all of these studies here, they're looking at either Campylobacter, E. coli, Salmonella, Listeria. They're looking in what is the industrial pre-pasteurization milk, and that's where I put the red dots there, IPP. You see that all of these studies here is based upon industrially produced milk destined for pasteurization. So if they say, well, there's going to be X% of salmonella in bulk tank milk, well, it doesn't really say anything about your production. And that's a challenge for you, is to say, well, you cannot compare my production to industrial pre-pasteurization systems. But that's also where we have the data, because there's not a lot of researchers that are getting money to work with you, or they're not getting funding, or they're not getting research proposals approved for working in your sector to look at this. Professor Ton Bars, who's here today, is going to speak to you a bit more about Wurzelmilch, the German system for safe raw milk that has existed since the 1930s. But he has also been looking at what are the levels of pathogens in this specific milk that has been produced under federally regulated systems and under strict control compared to other types of milks. And what he did was he took, over a period of 14 years, he looked at what are the prevalence of Salmonella, Campylobacter, verotoxin-producing E. coli, Listeria, and Yersinia in the Wurzelmilch milk, and he compared it to conventional dairies, and he compared it to pasteurized milk. And lo and behold, he saw that this raw milk produced under strict sanitary conditions had lower prevalence of most of these pathogenic bacteria than both the conventional dairies, but also in certain cases lower than pasteurized milk. If you look at it for the verotoxin produced in E. coli in the Warsash milk, it was less than 0.7% of the samples that were positive for the VTEC, but in the pasteurized milk, it was more than twice as high. So the data on pasteurized milk also shows us that pasteurization is not necessarily safe. If you look at it, we're about 10 times higher levels of Yersinia in pasteurized milk compared to Warsash milk. So pasteurization has been sometimes coined as something that creates a totally safe system, but we know it's not. And we saw that, I think, a few years ago with the problem even with milk powder to babies contained Salmonella. So those are some data showing that it's very possible to produce very safe milk using raw milk. Now, pathogen prevalence data is insufficient to assess the safety of raw milk. As was explained just previously by Dr. Delbes, they're so complex what really how the bacteria work together in the gut of them animals, but it's not just enough to say there's the presence of a pathogenic bacteria to say that it's a risk. We need to know the infectious dose. We need to know storage conditions, the consumer's health and age, the immunity of the consumers, and various other factors. So in order to quantify the risk, really what you need to do is to do a quantitative microbial risk assessment. And these are complicated statistical models that work from the stable to the table to quantify the risks. But these models also use model approaches, which are of course not perfect, and they also use some assumptions, which may or may not be right. So even if you do a quantitative microbial risk assessment, it may not accurately reflect the true risk. They are also dependent on really good data, and therefore it's really hard to do for raw milk because we really just have outbreak reports. But these QMRAs are said that they should be guiding the public policy decision. But how can the public policy then make decisions about raw milk when we just don't have the data and we don't have a lot of these QMRAs? There have been some QMRAs done for raw milk. And here's a list of these, and most of these have actually been done in Italy by Professor Giacometti, and he's been working with Italian producers that usually had vending machines. And he was looking at both risks from E. coli, Campylobacter, Listeria, Salmonella, and so on. And in general, these QMRAs, they're only specific to the region because what happens in Italy by farmers having a vending machine doesn't reflect what's happening in the United Kingdom or in Finland, right? But in general, when they've done these QMRAs, what they've seen is you have a low risk of illness. If you look at all of these here, what you see? Low risks. So they're indicating that it doesn't seem that the risk is terribly high. It's still there, but it might not be as high as it's pictured by many health professionals. So QMRA are a good tool to start assessing the risks of raw milk, but there are weaknesses with them. There's lots of areas where we need to keep working with them. But one of the interesting things was when I noticed from Professor Giacometti when he was doing these QMRAs in Italy was that he said that pathogen-free raw milk is difficult to obtain, but the risk of illness could be significantly reduced by simple control measures. And he said, good manufacturing practices on the farm. He highlighted this was really important. And then he also highlighted really important, strictly monitoring of the temperatures by farmers during the raw milk distribution. But then he also said enhanced educational efforts to the consumers for the importance of maintaining cold chains, reduce the domestic shelf life, and finally at the end, first of all, boiling the raw milk. And then I thought, okay, that last statement is so typical what many scientists are saying. You need to boil it. Well, and then you of course know that that destroys many of the beneficial properties of the milk. But that's many times where the scientific community are still at their state of where they still are. Now, how do you know these QMRAs are accurate? Well, Codex recommend that you really compare this, the estimates from these models with prevalence of risk and using good data. Well, we don't have good data. And then there was another study that looked at these QMRAs and said, well, we also need to take into account that when they do these risk modelings, they don't always take into account consumer behavior, because if you have a raw milk standing in your refrigerator and on day 4 it starts to taste a bit sour and not smell good, you're not going to drink it. But the computer models, they don't pay attention to that. So therefore you need to take in so many other factors that are difficult to model in statistical models. So what we have to deal with is really, mostly we have all of these outbreak data, and these are always printed everywhere. But it's interesting here because even in the United States, where the scientific communities and the health communities, health professionals are still very anti-raw milk and still always just highlight the outbreaks, they are actually seeing a reduction in the trends, in outbreak trends due to raw milk. There was two researchers in Canada that analyzed the data from the Center of Disease Control from 2005 to 2016, just the number of outbreaks, and that they put that in relation to the amount of raw milk being sold, and they saw that there was a reduction in the number of outbreaks that were happening due to raw milk. And they attribute it to a large extent to that the raw milk producers are becoming increasingly proficient in what they're doing, professional in food hygiene and understanding the risks and how to reduce the risks. And so the on-farm food safety programs are absolutely critical for you in order to maintain your sector and your passions. And then what I also see a huge need for right now is that we need a good risk-benefit analysis in order to be able to quantify these risks that are always highlighted in relation to these huge impact on reduction in asthma and allergies and atopes in improving the metabolic health of people. So in general, I would say that anyone that works in raw milk production really requires a high level of competence. And really it's like we need to go to traffic school. In order to drive a car, we need to go to traffic school. I think that in order to produce raw milk products and selling these direct to consumers, we need to be educated in these risks so that we can address concerns of people, and we also can know how to reduce these risks, because it's very possible. Because it really has been shown that good animal husbandry is key. Hygienic practices and biosecurity are super important, and it's not really rocket science. It's very quite straightforward if you just understand what to do, because that is essential for us in order to reduce this negative impression of raw milk products and raw milk, fluid raw milk. So we have the competence to manage these risks without having to use any type of final decontamination such as pasteurization. But we need to prove to the regulators, to the naysayers, to the doctors, and to anyone else that are skeptics that we are actually very professional food hygiene specialists. We're experts on our own systems. And this is very important not only for the people that are consuming our products, but also for a living agriculture community and for the health and the future of our children.